Here, we must have a big company and you have like 54 employees whose mean weight is 183.9 pounds. And we're also given that the population standard deviation is 121.2 pounds. And we're to test the claim that the population mean of all such employees' weights is less than 200 pounds with 0.10 significance level. Alright, so one thing that you should notice is that here it's in regards to population mean, and we're trying to test the claim. So it's a hypothesis testing problem on population mean. That means we should first figure out what the null hypothesis is and what the alternative hypothesis is. And when you look for the null and the alternative, look at something that has inequality or unequality. So here it says employees' weights is less than 200 pounds. Oh, by the way, because this is population mean, it's not proportion. If it was proportion, then you would think about the P, population proportion, but here it's population mean, so you look for mu. Okay? So the statements of the null hypothesis and the alternative hypothesis should be about the population mean. Mu. Okay, and here it says mu is less than 200, and when you have a strict inequality, or if you have something like mu not equals to something, then that's going to be your alternative hypothesis. So here it's less than 200. So that's your alternative hypothesis. And the null hypothesis is always equal to some value, so the opposite of this would be mu equals to 200. Alright, so now we have to calculate the test statistic, whose formula is you have to look at the difference between the sample mean and your purported value of the population mean, and you divide it by the standard deviation of the population over square root of n. So that's the formula, and we have all the values, so let's plug them in. So you need to put 183.9, that's the sample mean, minus mu would be the population mean, which is assumed to be 200, and then you divide it by 121.2, that's given as the sigma value, over square root of 54. Okay, now we have to calculate this using the calculator, but when you put these numbers into the calculator, make sure that you have parentheses around here and here. That's because without the parentheses, the order of operations can wreak havoc on this calculation, and you end up with a totally wrong answer. Okay, so make sure you use these parentheses. Let's do them. So here's our calculator. Let's turn it on, and then I need parentheses, and then you have 183.9 minus 200. Then I get to close the parentheses. Then divide by, open another parenthesis, then you put 121.2 and divide it by the square root of 54, and then you put parenthesis, then enter, you get negative 0.976. Okay, so we get some value for the test statistic, but now the question is whether this test statistic is significant or not. And to figure that out, you have two ways. One method is to use the p-value. Another method would be to use the confidence, the critical value, right? Okay, so I'm going to show you both, because depending on the question, sometimes they might ask you to do one over the other. So first, the critical value method would be, sometimes it's called the traditional method. The traditional method is to first identify the critical value. So because your significant value is 0.10, and because it's a strict inequality on the left side, it's a one-tail test. So strict inequality means it's a one-tail left, one tail left test, okay, one left tail test. And in that case, you're looking for this critical number here, which will make this area as a significance value, which is 0.10. And when you are given the area or the probability, actually the area under this distribution has the meaning of probability, okay? So since this value is 10, what you want to do is to use the inverse norm. So you go to second vars, you use inverse norm, okay? Inverse norm is used whenever probability or the area is given and you want to find the critical value. So I put 0.10, enter, and I get negative 1.28. So the critical value is negative 1.28. And then we can say that since negative 1.28 is less than negative 0.976, we see that negative 0.976, our test statistic belongs on this side. But because this is a left tail test, this left side of negative 1.28, that's what we call the rejection region. And because negative 0.976 is on the right side, we see that negative 0.976 is not in the rejection region, so we cannot reject H0. Okay. Now let me show you the second method using the p-value. For the p-value, still you need to know that this is one tail and left tail test. And because our test statistics is negative 0.976 and we're using the left tail test, that means the p-value is, in the case of left tail test, it's the left side of our test statistic. So that's the value of p. And when you're given this value and you want the area, you use the normal CDF function. So let's go to the calculator and use that. So second vars, and you do normal CDF, and you want to put in the minus 0.976, and its value is 0.165. So we know that p is 0.165. And because 0.165 is bigger than our significance level, that means it's not a sufficient evidence to reject H0. So you end up with the same conclusion. So either method should give you the same conclusion. So we know that we cannot reject H0. But when you write your conclusion, you should write in a human readable form. If you just say we cannot reject, we cannot reject H0. Rather than saying we cannot reject H0, you have to write down what it means. It means that there is insufficient evidence. So the evidence we have, I mean, it does look slightly smaller than 200, right? So you may have hoped that, oh, this could show that actually the average weight is less than 200 pounds, because 200 pounds sounds a lot, right? But there is insufficient evidence that the the employee. So there's insufficient evidence to prove that mean weight of all employees is less than 200. So in other words, you have failed to adopt this alternative hypothesis. But what's really important is that often people confuse this with saying that it is true that the mean weight is 200, but that's not what it's saying. I mean, here this sample already seems to indicate it's probably smaller, but it's not strong enough. I mean, if this mean had been like something like 163, then we would definitely go for rejecting the null and say, yeah, indeed, the employees weight less than 200. But here, we just failed to show this, so you just have to say it. There's insufficient evidence to prove something. That's how you should summarize your result.